Hello everyone, today I'm going to show you guys how to calculate the pressure inside the manometer. So in this case, we find that a manometer is like quite common in the exercises that we have in the textbooks or in other types of problems and answer on the internet. So here I found a problem that consists of four different types of liquids, and it is a double U-tube manometer. Okay, so let's start with the equation of the hydrostatic equation of this. We can see that the flow is on the same elevation from the same point from fresh water to seawater. It's on the same elevation, but it has different types of liquid, so it can have the same pressure. So the equation goes like we name the fresh water as point A, and we name seawater as point B. So we write the equation as pressure at point A first, and then so remember this, if it's going down, if the liquid is going down, it means that it's addition. And if the liquid is going up, it's like subtraction. Okay, so we can see that the liquid is going down there, and up until mercury, the height increased, and it means that we have to do subtraction here. Actually, there's something like the formula that we subtract the height from the lower place to the upper place, so it must be a minus sign. So we can just remember that if it's going down, it's addition, and if it's going up, it's subtraction. It's easier than computing all the formula or the equation again. So in this case, we can see that it's going down there. We have plus sign of the water and the height of the water. So from the mercury, you can see that it's going up. When it goes up, it means that it's subtraction or the minus sign. So we can say that if it's the minus sign, we write the formula of the pressure, and make sure you name each of the variable as Hg, which is like mercury, so that you won't get confused. So you can see that from the point of mercury to the oil, it's going up, which means that we also have to subtract it. So when we subtract it, as the same thing that we have to repeat is that we have to write the label of the liquid so that we know what type of number that we have to substitute later. So in this case, after we finish everything, we return back to the seawater. So we can see that we return back to the B point. So we write the pressure at B. Okay. Okay. So after we have finished writing the equation, we have to either move all the variables to the right side or remove the pressure PB to the left side. But in this case, the question was to ask the difference between two points is A and B. So we have to say it's like PA minus PB, and we move all the rest to the right side. So don't forget to change the signs, because you switch sides to another one, so it's everything is going to change completely. So after we rearrange the equation, it's time for us to substitute the numbers. So the given density of it is will be shown in a few seconds. So right here, we don't have to remember all of the densities or the specific weight, specific gravity. It will be given in the exam or in the problem. So in this case, we all know that water is 1,000, but we have to remember the unit. Actually, it's not like we have to remember, but it's like common sense that we need to know like the m cube or m square, the meter square, meter cube, because when you have to cancel out the unit at the end of the exercise, it might be a bit confusing here. So make sure like you always write the unit, um, not always write the unit, but like always remember what is like of the units of each component. Okay, so it's time for us to substitute all the numbers inside the variables. We have, I wrote it as delta P. The reason is that it's the difference between pressure of the two A and B, 2 points. So we substitute all the numbers inside the brackets. Um, in this case, I skip a line. It is supposed to have, I factor out the density, the gravity, because all of the formula, it's supposed to be density multiplied by gravity and multiplied by the height. So all of the components here have one common factor, which is the gravity. So I just factor gravity out. So in this case, we keep substituting, and in the end, we will have the pressure, the difference between pressure of 2 points. So we have to also say what does it mean? What does the pressure between 2 points mean as the final answer? I'm sorry, I made a mistake here. It's supposed to be a multiple sign. It's 1035 multiplied by 0.3. It's the density multiplied by the height of the liquid. And finally, we multiply by 9.81, which is the gravity. So in this case, I want to show you guys that the unit are different, a little bit tricky. So the unit of density multiplied by the height, it's having the kilogram per meter square, and the gravity has the unit of meter per second square. So what we need is the pressure, and the pressure is having the unit of the pressure is kilopascal, or but we cannot like just write kilopascal, right? So we have to convert it to kilonewton per meter square. In this case, we multiply by 1 kilonewton per 1,000 kilogram meter per second square. So in this case, we will get kilonewton per meter square, which is equals to kilopascal. Okay, so the difference, or we call the delta pressure, is equals to 10.3 kilonewton per meter square, or kilopascal. Okay, so in this case, we finally have the difference between the pressure of two parts, 2 points, A and B, which is A is the fresh water, and B is the seawater. So we can say that the pressure in the fresh water is 10.3 kilopascal higher than the pressure in the seawater. So that's the final answer that we have to write it down after calculating for the difference of the pressure. Can just go back and see, take a look back at the diagram again. We can see that the fresh water and the seawater is actually at the same level, or we can say it's the same elevation in the manometer. So normally if we see that if two liquids are at the same level, it means that the pressure is the same. But here we have different liquid, so don't be tricked by how it's in the same level. So if it's different liquid, it means that it has a different pressure all the time. So yeah, that's all for part 1. Thank you.